my screen share going. Can you all see my screen? Oops. Wait. Where did I pause it? All right. Let's put this on the side. Minimize this. Okay. All right, excellent. Welcome, everyone. Make sure I'm in the right. All right. Let's see. So, we are still in week 12. We just started talking about MongoDB as an alternative solution for permanent storage. We had been discussing storing data in a relational database, MySQL, and so we are now exploring an alternative solution where we can store data in a non-relational database, which is MongoDB. We talked about installing the database and starting the database and interacting with it using the Mongo client. So today we're going to be talking about how is that we can interact with the database programmatically from JavaScript. Basically, what we want to be able to do is more or less what we set up earlier, having Java use JPA talking to a relational database. We're trying to replace that or augment that or provide an alternative solution where we would have the middle tier. Instead of Java, we would have Node.js, so JavaScript running in the middle tier, and talking to a database that instead of Java talking to a relational database, MySQL, we're going to have Node.js talking to MongoDB, a non-relational database. So we're going to be doing that with a library called Mongoose. And we're going to be discussing how that we can programmatically connect to the database and then use models and schemas to be able to establish connections and start inserting data, retrieving data, updating, deleting, and so on and so forth. Okay, so that's the plan for today. We are finishing up week number 12. There is an ongoing assignment number 8, which is due April 19th, so a while from now. We won't have class apparently this upcoming Monday, the 12th, and the focus of next week will be on the project. So we'll be covering topics that are useful for you to complete your project. So if you have questions about and challenges that you might be having with your projects, please bring them next week. Obviously, there's plenty of office hours that you might want to come and discuss. But yeah, I want to give a chance next week for folks to come with questions that we might be able to solve for everyone in class. Not necessarily specific questions of why is this crashing in my computer, but things that are a little bit more generic that might be useful for everyone that we might want to be able to discuss in class. It looks like there's a question on the chat. I think April 19th should not be a holiday. Patriots Day. Okay, so all right, I'll check to see if indeed Monday the 19th is not a holiday. Yep, thank you. Yeah, I'll take a look at that. Also, the last day that we'll be meeting is April 21st, that Wednesday. That day, we're going to have a review of the final exam. Same thing like we did for the previous exam. We will be discussing different types of questions, giving you sample questions from previous exams, and then a couple of days later, on the 26th, there will be the actual final exam. And the final exam will be more or less the same format as the previous exam. It will be online, mostly fill in the blanks and multiple choice, and you'll have several days to take it, right? I'll make it available for 3 or 4 days, starting on Monday, April 26th, and you will be, completing that on your own. What else? I think that's it. Any questions? Okay, so if there are no questions, let's go on to the material for today. So let's talk about Mongoose. So we've been discussing on how is that we can interact with the Mongo database from the command line. We showed you how we can start the Mongo database server and then connect to it with a Mongo client. And we showed you how to implement several commands right from the command line. We will show you how you can list the databases, the collections. You can query it and update and insert from within the client. And so we want to switch gears a little bit and show you that we can do many of the things that we can do manually from the command line. We can also do them programmatically from within our source code. So let me just demonstrate where we left off. I'm going to start a PowerShell here, and I'm going to go in the directory where we were doing all our work. Let's see, I believe we were documents, NEU, web dev, 21, section 1. And let's see, we had here the server, Node.js server here. Let's go, there we go. And we had created a Mongo directory, I thought, maybe. It's not here. Where is it? Well, nevertheless, we can create it right here, right? We can say, we can create a directory right here, a data directory that Mongo can connect to and store its data wherever you want to create it. So I'm going to create it here. I'm going to say make directory data, and then we can start the database so that it connects to this, so that it uses this directory to store its data. And we can use the MongoD for the Mongo daemon, right, to start up and listen to a particular port and then store its data in this path that we just created, or the data directory. And you can do that with the db path command that we discussed last time. You say data, it starts up listening to port 2717, I believe. It's listening somewhere here. I notice that the directory is this one, the data directory, right, that we just gave it. And somewhere here it said it's listening at port 2717 somewhere. All right, so we're going to leave this up and running. There it is, port 2717. In a separate PowerShell, we're going to start up the command, another command line where we can connect with the Mongo client. So let's start off PowerShell again. And this we can do anywhere we want, right? It doesn't have to be under any particular directory. All right, so let me make that a little bigger. So we can start it here. We can say Mongo. So this is going to connect to that server that is up and running, listening to 27,000. We can look at the databases, and we had stored some information in here in a database that in this particular case we called a whiteboard, right? Because we are creating a whiteboard application that somewhat challenges the current Blackboard application that it's an online learning management system, and we have some content in here, some collections that we had stored in there. So if we go in there, we use those databases. Right? We can say use whiteboard, and it switches over to a whiteboard, and it might have some information that we might have stored in there. We can say we're going to show the collections. We have users, sections, modules. You can have courses. We can have all sorts of things in here. In particular, we want to be able to store things such as quizzes, right? So that we can work on the homework. Yeah, so we can store information in here about quizzes, and then try to communicate with the database from within Node.js, from an application that can then export this data model for a user interface that might retrieve the information from the database. Okay, so for instance, if we take a look at the data that we might want to store in here, let's take a look at the assignment. And I believe I gave you some information that we're going to store in there. Let's see, for instance, these quizzes, right? So let's insert a couple of quizzes in there. So we can say, let's see, show collections. So, okay, so we don't have quizzes collection. So we can insert into the quizzes, DB quizzes, insert, okay, and we can just paste in here the object that we are using. So DB ID 103, 123, and we insert it, right? So we can take a look at the content. We can say db.quizzes.find, and we see that indeed we have that record inserted into the database, right? We don't call them records, we call them documents, right? So we can insert a couple more. Let's insert this one right here. So for instance, this would be, we can insert quiz number 2 with the ID 234. Let's do another one, quiz number 3, and then quiz 345. And so now we have these 3 quizzes, right? So as opposed to having this stored in a file, right, in a directory, we are instead trying to replace that, right, and have that stored permanently in this non-relational database, MongoDB. Once we have that, we can start to see how we can connect and communicate and retrieve the data from within the database, right? So to do that, we're going to be using a library called Mongoose, right? I encourage you all to be familiar with the Mongoose library. Okay, so if you go to Mongoose, there we go. This is the landing page for the Mongoose library, and we're only going to be using a little bit of it. With that, it's actually going to go a long way, right? But I definitely encourage you to explore beyond what we're going to be covering here in class. It's a great skill to put under your belt. And to connect to a database and start interacting with the database is fairly simple. We're going to require a library, the Mongoose library, and then we're going to connect to it. Okay, so it's that simple. In the connection, you need to provide a connection string, which is going to point to the local machine where it's running on our machine that's listening at the default port. And then we're going to list the database that we want to connect to. Okay, so to do that, let me see. This is the I believe this is a directory. Yeah, this is the correct directory. So this is the running server that we had from last time, right? Where we had a couple of controllers for the quizzes, right? That currently, right, is retrieving data from this JSON file. Well, we want to replace that. We want to replace it so that instead of using these hard-coded objects, right? That there's these arrays, right? We want to instead replace this so that it uses the database content, right? Oh, it looks like we had added some course information, and we can fix that, right? Let's fix that. So, for instance, we can go back here and update this. We can say DB quizzes. We can say I want to update the quiz whose ID is 123. I want to set a new field called course ID ABC123. Let's do that. Even though we're not really going to need it. There it is, right? So if we do a find, we'll notice that now we have this new field for that quiz. Although it's not needed because the way we're gonna implement it is that the same quizzes are gonna exist for all the courses, right? But if you wanted to have somewhat of a foreign key that says that these quizzes are for that course and these other quizzes are for some other course, then yes, you would implement this course ID very much like what we did for the widgets, right? For the widgets, we had we were using a topic ID to store what the parent topic ID was. Even though the topic ID was being stored in a separate database, the generic server database, right? We did use it, right, to be able to group all the widgets for a given topic, right? So similarly, we can do something like this as well. Right? So we can update the quiz 234, right, and use this course ID instead. Right, so it's course to ABC 234, and let's update for quiz 345. We're going to update it for ABC 234 as well. So basically part of the same course, presumably. Okay. So if we look at all the quizzes, we have basically the same information that we had stored here in this array. Right, we now have it stored in a non-relational database. So we want to come here and basically replace the use of this array. We want to replace that with the access to the relational database, right? So that's what the focus of today's lecture is going to be. Okay. All right. So let's do it. So the first part, or the first step, is to install the Mongoose library, right? So to install the Mongoose library, it's simple. The library is called Mongoose, and we already know how to install Node.js libraries, right, using npm, right? So from the terminal, you'll say npm install, and we're going to paste the Mongoose library, save. So that's going to download the Mongoose library, right, and it's going to copy it inside our node modules, right? And we should be able to find Mongoose somewhere. There it is. Mongoose was installed. Okay. All right. So now that we have it installed, we can now establish a connection to the database, right? And then we can do it. We can have maybe a separate file where we can actually establish the database, but it's only 2 lines of code. So here, it's a good place as any in the top level of our server.js, right? And these 2 lines is all we need. Okay, so let's review these 2 lines. So the first one is just importing the library, the Mongoose library. And you remember, right? If whatever you're importing is just quoted, right? It doesn't have a dot in front of it or have a path or anything like that. That means that require is loading the library from your node_modules. Okay, so it's looking for it in there, and whatever the Mongoose library exports, that's what gets bound to this local variable here. So Mongoose is whatever Mongoose exports, right? And it's an object that contains several functions, right? In particular, it has a connect function, which does exactly what you think it does, right? It connects to the database, and the connect function takes as argument, right? This first argument here is what we refer to as the connection string, right? The connection string. This is somewhat similar to what you've seen already when we were doing this in Java, right, where the first part of the connection string was something like MySQL. And so that first part is called the protocol, and it's dependent on the vendor, right, the provider, right, of whoever you're connecting to. So we're not connecting to MySQL, instead we're connecting to Mongoose. And each vendor has a different protocol. So you have for Oracle, you have for SQL Server. So each Postgre or Firebase or whatever vendor, it will have a different protocol. So this one is the standard for MongoDB. The rest is just like a URL. It's got the localhost or the location of where the server is running, the machine where it's running. Right now, it's running on my machine locally on my laptop. But this could just as well be running, halfway across the world. Right? If you know the machine name, or if you know the IP address of where this is running, right, you can just type in here and it'll connect remotely to that machine. The port by default, the Mongo database listens at 27017. That's the default. And finally, this last piece is the database that you're connecting to, right? So in our case, we're connecting to the whiteboard database, right? Which is the database that we are using, this one right here. Okay, and that's the current one where we've been storing data. Okay. All right, so that's it. This just works, right? It's going to connect us to the server, right? And then we're ready to go. All right. Okay, so how do we do this? Well, let's run it and see what we have so far. I'm going to run the server. And if you remember, we had a couple of web services that allowed us to retrieve data, right? With something like localhost 3000. Was it 3000? Let's see. Yeah, 3000. And we were able to retrieve the quizzes. Okay, and this is what we're trying to replace. Right, this data right now it's coming from the array. We want to replace this to be using the Mongo database instead. How do we do that? So the way we do it is as follows. Okay, so we have the controllers, we have the services, and we have the quizzes down here. And right now the services is just like, for instance, this is the query that we just did, right? It's this one, find all quizzes. Okay. And right now it's just retrieving this array. Okay, so what we're going to do is that we're going to create, right? We need to create, very much like we did for Java, right? We created a repository, right? And the repository was responsible for providing some high-level generic functions that allowed us to interact with a table, right? We declared a class. The class provided was annotated and told us, right, what it was mapped to. Also, the class told us what the various properties were, right? ID, name, type of the widget, right? And so the class gave us the structure of the data and also where it was mapped, what table was mapped to the relational database. So we need to do something similar here. Okay, we need to establish what the structure of the data is, right, from the point of view of the client here, whoever is connecting to the database, right? In the Java side, it was also Java services, right, that we're using the repository. Here, we have to do something similar. We need something that plays the role of the repository, that bridges the world of JavaScript and bridges the world of the database, and gives us some API that allows us to insert, to retrieve data, to CRUD something, right? CRUD something that we are going to establish what the schema is. Now we had said that in non-relational databases, there are no schemas, right? That, there's no validation here of whether I'm inserting something correctly or incorrectly, and that responsibility would fall on the application, right? It's not going to be the responsibility of the database to validate that you're inserting certain things that have the correct structure, because there are no schemas. Let's see, there's a question on the chat. If I'm not wrong, it's used to add into dependencies. What's the dash save? Oh, yes. There's a question on the chat says, what do we use dash save for? Yeah, when you install something in the using npm, the dash save makes sure that the dependency is entered here in package.json. So there it is. So Mongoose. So that dependency is added in the dependency property of package.json by using the dash save. Okay, so make sure that to always put the dash save. Otherwise, it could be that this runs perfectly fine locally on your machine, but then when you deploy it to Heroku, it might not work because it fails to have the dependency listed here. And then what Heroku does is that it reads your package.json file, right? And it reads the dependencies in your package.json, and then it installs all your dependencies. And if they're not listed there, right, you might be missing the Express library or the Mongoose library, which you have locally, but you won't have it remotely. So make sure that to put the dash save. Yes, thank you. Okay, so how do we do this? Right, so what we're going to do is the following. Okay, we're going to create here a directory. Let's see, is there a question in the chat? I know Redux has just npm install, blah, blah, blah. So how come it still works on Heroku? So one of them was the client, right? This is the middle tier. So it's a little bit different. The when we do the client, right? It's being maintained by Create React App, and Create React App has a lot of magic that is happening behind the scenes that is being taken care of for you. In this case, we are doing it all by ourselves, right? We don't have a setup infrastructure that starting the server automatically, that it's deploying automatically, that it's compiling things on the fly behind the scenes. Right here, we're doing everything by hand. Okay, so when we did React or Redux or anything like that, right? There was a Node.js server that was running in the background, right? That was listening for changes in the file and automatically transpiling all our JSX code into JavaScript, right? And repackaging everything for us. So yeah, so a lot of things were happening for free in when we were doing React. So yeah, let's continue here. So what we're going to do here is that let me check this out. We're going to create a directory here, just like we did in our. We're going to create a directory where we're going to handle everything that has to do with the database, right? So we're going to we'll call it maybe DB. And here we're going to establish, we're going to, the schema of what it is that we want to connect to, okay? So for instance, we're going to create a directory for quizzes, and we're going to create a directory for questions, okay? Now, in the quizzes, we're going to create two files. One of them is going to be the schema of what it is that we are trying to interact with the database, right? So this is going to play the same role as the widget Java data model, right? What we had in there, we had all the fields, right? You know, the ID, the topic ID, right? It had the title of the widget, it had the type of the widget. So it declared the structure of what it is that we wanted to store in the database or retrieve from the database. Remember that? It also had the mapping of the table. It says that, you know, this widget class maps to that table over there called widgets in plural, right? So I had those two important parts here, right? So here we have conceptually the same thing, right? But obviously it's a different language, it's a different infrastructure. You do it slightly differently, but conceptually it's the same, right? So we're going to create a new file. We're going to call it the quizzes schema. Okay, and again, this is playing the same role as a class. Okay, all right. So how do we do this? We have to establish the structure of the data. Okay, so we're going to do first. We're going to bring in the Mongoose library. Okay. Then we are going to create the actual schema. So it will be quizzes schema. And to do that, Mongoose provides a function to do that. Right, so we're going to do mongoose.schema. There it is. Right. So in here, we're going to establish the structure of the data. Right, and as we see it, we see that the data has an ID, a field called ID, which is a string. Right. Let's see. We have a title field, which is also a string. It has a course ID field, which we probably don't care about that one. And we can put all sorts of things in here, right? Anything that we want to store or retrieve from the database, right? So again, this plays the same role as the Java class, right? In Java, it establishes the structure from the application's point of view, right? From the database point of view, we had tables that used you know, create table and varchar and int and auto increment, blah blah blah, right? So there were two worlds. One was from the point of view of the application level was classes. From the database point of view was tables. Here we have something similar, right? From the database point of view, we have these collections, right? These collections. But from the application's point of view, we also need to have a structured representation of the data as it lives in memory, right? As we load them into memory. Let's see the question in the chat. How to make MongoDB generate ID for us? Like with it? Yeah. So correct, right? If I leave out this ID here, and here when I inserted it. When I inserted the when I created the quizzes, when I did the insert, I guess when I inserted the quizzes, I added the ID. If I don't add the ID, it will create it for me, right? So if I do db.quizzes.insert, right, and I don't provide the ID, right, and I just have title, you know, quiz 4, and I don't provide the ID, right? And then I list all the quizzes. You'll notice that it creates an ID for me. See that? So by default, it creates the ID unless you provide it. Unless you provide it, right? And otherwise, it creates it for you. So by default, it creates it for you unless you override it. Okay. For this assignment, we're asking you to use these specific IDs only because it'll make it easier for the TAs to be able to grade you. Okay, so I'm going to remove this. I'm going to say db.quizzes, and I'm going to remove this here. And then notice that I don't have it anymore. Okay. But yeah, so if you don't provide it, but here I am overriding it. I don't want to use the default implementation. I want to provide the IDs. Okay. But again, if you don't want it, then you can just leave it out and we'll use the default implementation. All right. Okay. So yeah, so this is the application's point of view of what the structure looks like. Then, again, just like we did in Java, right? There was an annotation that says that the table that class mapped to, you put it in an at table, name, and then widgets. So same thing here. There is an argument you can configure here the collection to which this maps to, right? And this maps to the collection called quizzes. Okay, so I'm going to say quizzes. And so there it is. So now we have fully described the structure of the quizzes. And we're going to export this. And so this is module.exports equal quizzes schema. Okay. All right, we're done. Now we have to do more or less what we did for also we did in Java. What we did is we created a repository. Okay, and then we created all the APIs that did the actual CRUDing based on the repository. Okay, so let's do that. Let's do that. And so we're going to do JavaScript, and we're going to call it now in Java we call it the repository, right? In Mongoose, right, we call it the model, right? A Mongoose model plays the same role as a repository in using JPA, right? So we're going to say quizzes model, okay? And very much like the repository was like one line long, right? It was like, or a couple lines long. Same thing here, right? We're going to first we're going to bring in the schema. So the quizzes schema. I'm going to require the quizzes schema, and we're going to create the model. So we're going to say the quizzes model is, we're going to create it. So it's Mongoose oh, we need Mongoose. Bring in Mongoose. Okay, and then we can create the model. We can say quizzes model. It's we're going to use mongoose.model. Okay, so again, this is very, very similar to what we did in Java, right? When we created the repository. Remember, the repository took two arguments. Okay, the first argument was the class, right? So when we created the widgets repository, right? When we extended, I think, CRUD repository, and the first argument to that CRUD repository was the widget class. Okay, this is almost similar as well, but here's the second argument. So it would be, and the class widget, the same role is being played by the schema here, right? So I'm going to put here the quizzes schema. Okay, and again, it plays the same role as the widget, right? When you used it in the repository, right? It gives the repository, it's being configured so that it knows what it is that you want to CRUD, right? And then it provides you with generic functions that allow you to actually implement all your CRUDing. Okay. Now the second argument, the first argument here is just a unique string, right? This needs to be a unique string. A very common name is to give it the the name of the thing that you are CRUDing. In this case, it's a quiz, right? And then followed by the keyword model, right? That's a very common name. It needs to be unique, right? So you can't use quiz model anywhere else when you're talking about a Mongoose model. And that's it. That's all you're going to do. So quizzes model is going to give us all the generic functions, that we need to interact with the database. Okay. And and so we're going to export it and say module.exports equal quizzes model. All right. All right, excellent. So we are ready to start using this. Let's go back to our service, right? And let's try to rewrite our quizzes service so that instead of using this array, it uses the model. Again, the model, the Mongoose model is going to play the same part as our repository. So we need to bring in the repository. So let's bring in our model. So it'll be const quizzes model. It's going to be require. We're going to go up one again, DB, and then quizzes, and then model. Okay, so we required it. Now we can start replacing our array. Okay, so instead of find all quizzes, right, returning these quizzes here, this, all right, we're going to instead, we're going to comment that out. What we're going to return is whatever the quizzes model returns. So we're going to return quizzes model dot, and here we're going to have all the generic functions. There it is. See that? We have remove, find by ID, find one, right? Create. There's a whole bunch of functions in here, right? And in particular, we have find, which I don't see it here. Why is it not listed here? Find. Oh, there it was. There it is. Find. Okay. So this is the equivalent of find all. Remember in the repository we had a dot find all, and that find all returned I think it was like editable, right? And then we had to cast it into a list or whatever, right? Well, this dot find plays the same exact role, right? And it actually what the folks at the who wrote Mongoose, they made an effort to make sure that these functions, the dot find, looks very much like this dot find right here. This dot find. So it has the same signature, right? And it can take the same arguments as the dot find that you have here at the command line. So this dot find, even though this is from an application, right, it behaves the same way, right? What does this do? It's you know, as opposed to this one is running inside of the Mongo client, whereas this one is running inside of your application, right? Okay. Yeah. So from the service point of view, we're done, right? We're done. Well, at least with this function, we still need to take a look at all these other ones, right? But as far as find all quizzes is concerned, it's done, right? We'll implement the other ones in a minute. Now, because this was an array, used to be an array, because it used to be an array, this return here is a synchronous execution. And by synchronous, it means that not until you're ready to return this, right, the execution stops, right? It stops waiting for to have this data, and then we return with that data. So that in the controller, right, in the quizzes controller where you have find all quizzes, this is a synchronous call. Synchronous means there's a thread that comes in here, it's running, and quizzes doesn't have a value until this comes back, right? Execution blocks, it stops for this function, not until this function comes back and this continue, and then we can send the response, right? Now, because we've switched the implementation to use .find doesn't work that way. .find is asynchronous, not synchronous. And we already had a chance to play around with asynchronous communication, right? We use in JavaScript, we use what are called promises, right? And promises allows us to synchronize, right, and talk to asynchronous APIs, right? So this dot find, it does not return an array of JSON objects. It doesn't return this nice 3 quizzes, right? Instead, what it returns is a promise. Returns a promise. So here in the controller, here we're not getting the actual quizzes. What we're getting is a promise, right? So we're going to rewrite this so that it's asynchronous. We're going to do quizzes, find all quizzes. Okay, a promise comes back. So we use then. All right, and in this then, so unlike the promises that we get in a browser, notice that there's no browser here, right? In a browser, it's embedded inside of an HTTP, and it's the body, and it needs to be parsed. We get a response, and we need to parse that JSON, blah blah blah. So it's actually 2 thens, dot then, right? 1 dot then to wait for the response from the server, and then another dot then to parse out the data from the body. Here, there is no intermediate, right? There is no body, there is no HTTP, right? No headers, things like that. Instead, what we get here is already the data, right? So here we actually get the quizzes, the actual quizzes from the database. Okay. So these are the quizzes. We got the data. Now we have the data. Now we can respond. We can say respond.send quizzes. Okay. All right. So yeah. So this is the asynchronous version. So this is the asynchronous version of this synchronous version down here, up here. Let's restart the server and let's try to now try this. Let's see. Okay, we start the server. Let's go back here and refresh. I'm not quite sure this worked because it looked identical to what we had before. Let's add something to the database just to confirm that that this actually works. So I'm going to create a new quiz, and I'm going to give it a new ID, and it'll be maybe 456. How's that? 456. And this is quiz number 4. Let's insert that. Oh, not remove. Sorry, I meant insert. Insert. There we go. Let's try to find all the quizzes. There we go. So we got now 4 quizzes. Let's see if this worked here or if it blew up. Let's refresh. There we go. Notice that we are indeed retrieving data from the database. Okay, we're connected. Yay. So we were able to replace find all. We're definitely able to replace find all. Let's work on this one. Find quiz by ID. All right. So let's go back to the service, right? And so we're going to try and replace this right here. Okay. So I'm going to comment this out. And instead, I'm going to return this. Let me copy that. And let's paste that here. So if I do a dot again, notice that there's a whole bunch of functions here that are very useful. These are the very similar functions, right? That are very generic. That were available also in the in our repository, right? We had find all. Find by ID, right? So same thing here. There's a few of them, right? In particular, we're going to use this one, find by ID. Find by ID allows us to send in an ID, which is going to be pattern matched against the primary key. If it finds it, it's going to return a promise to come back with that particular document. Okay, so if we go back to the controller, right? This is the parameter that we're parsing from the path from here, and we're going to pass it to this function. But this function now is no longer synchronous; it's asynchronous, right? So let's rewrite this. Right? Let's comment this out and paste that in there.
So instead of this returning the actual quiz object, it's going to return a promise, which we need to handle it, right? And right, there is no response. There's no response. Instead, it's going to come back with the actual quiz object, right? And then we are ready to send that back to the client, right? That's it. We were able to modify, right, what used to be synchronous code into asynchronous code, right? So let's try it out. Let's restart the server. Okay. All right. Let's see. Let's look for quiz number 456. So quizzes, and then 456, like that. There we go. Right. So we were able to retrieve 456. So it looks like it's also working fine. All right. Any questions? Does this make sense? Right. So let's practice this again. Right. Let's practice it again. Let's get you going with a model and schema for the questions. Right. Let's try it again. Right. Again, we're going to have a quiz, a schema, and we're going to have a model. Right. So we're going to have, for the questions, it'll be questions schema. Right. And for the questions, I don't believe we have any questions. Let's, I think the assignment gives you a couple of questions. There we go. So these are all the questions. So let's insert a few of these. So here's the database. We can say db.questions.find. We don't have any questions, right? Because if we show the collections, there are no questions in there, right? Yeah, we only have quizzes. So let's insert a couple of questions. So db.questions.insert, right? And yeah, we need to insert something. So let's insert this right here. Let's paste that in there. Oops, didn't seem to like that. Let's see. On-call exception, syntax are expected. Expression got a parentheses. Oh, maybe because it's one line, maybe? Let's see. Maybe because there's a break. Let me try that again. Enter. Okay, looks like we were able to enter. And let's look at the collections. Okay, looks like we already have questions in there, right? And we can find all the questions. DB questions.find. Yeah, we got a question there. Perfect. Okay, let's insert another one. Insert. And we'll insert this one. Probably have to do the same thing. Put this in one single line. Otherwise, it'll complain. There we go. So let's insert another one. Copy that. And let's paste it in here. Okay. Let's do a find. Okay, we got two questions. We do a pretty. We got two questions. There's another one. Let's do this one. Let's copy that. Insert, paste. Okay, you get the idea, right? We're inserting those questions. Also notice that all these questions also have a quiz ID, which we're going to be using, right, as a means of knowing that these quizzes or these questions are related to a particular quiz. Okay. So yeah, so we've got that. You can go on and finish this up on your own. But let's focus on creating the schema. Okay. So again, so the way we create the schema, there it is. We have we load first the library, const Mongoose. We're going to require Mongoose, and then we instantiate a a questions schema, which is from mongoose.schema. And here's where we'll establish the structure of our data, from the client, from the application's point of view, right? We have the ID, right? It's going to be a string. We have what else? We have the title of the question. We have the question itself. We have what the correct answer is. We have the actual. So this answer here, it's not part of the question API or the question schema, but it'll be useful later on for the attempts. Okay, so that when folks answer a question, we need to be able to store what was the student's answer, right? So that we can grade them. So the answer is going to come into the server. We're going to store that answer in the database, right? So that we can have a permanent record that student answered, right, this question. And that was their answer. Oops. What else? Also, we're going to have type. So this type, notice that it is going to be a string, right? Because if you remember, there were different types of questions, right? We had multiple choice, we had true false questions, right? And so there were strings, right? The type was a string, but we want to make sure that those strings are valid strings, right? That we don't want folks just storing any string. We want to create a how do you say that? A constraint. We want to constrain that string so that it you don't inadvertently misspell it. So to do that, we can instead of just saying string, we can say type string, right? With a curly bracket in front of it, and then say that the valid values for this type string comes from this enumeration, right, of the valid strings that are listed here in an array of strings. Okay, so that if you try to set the type to be anything other than what's listed here, you're going to get an error. Okay. All right. What else? Choices. Right. This is for the multiple choice question. So for the multiple choice question, it is an array of strings, and the way you establish the data type, saying that the valid values for choices is an array, see the square brackets, right, and the internal type, so an array of strings. We're also going to want to tie it to the collection questions, right? So we're going to say that the collection that we're storing all this information is the questions collection. Okay. All right. Let's export this. Exports equal questions. What do I call it? Question schema. There we go. Okay. All right. Excellent. So we have that. So now we need the model. Now the model. All right, so we have the schema. Okay, so I had suggested that the questions would be embedded inside of the quizzes. Do we need that? Do we need that? I don't think we need it, but let me just point it out for you. Let me copy this. I'm going to put it in the schema, right, in the quizzes schema, even though we didn't have it earlier because I want to discuss it. We're probably not going to need it, but I do want to discuss it. So Mongo, as I mentioned in the previous lecture, right, allows you to store arbitrarily complex objects, JSON objects, and where an object, and a top level object can contain other objects, and those objects can contain arrays, can contain other objects, and you can have an arbitrarily complex JSON object stored in the database. Here we're saying that the questions field is not a primitive data type like these over here. Instead, it's an array. It's an array. Very much like the question schema, we're saying that choices is not a primitive data type like these strings, not even like type. Type is also a primitive data type string, but it's an array of strings. So it's a complex data type, right? So this one is also, it's a complex data type. But whereas choices is an array of primitive data types, it's an array of primitive data types. You can go a little bit more complex. You can say it's an array of something more complex, right? Where I'm going to store an array of, right? It's going to contain object IDs, And what are object IDs? It's these guys, right? These over here, these, right? Actually, this would be strings, right? This would have to be a string. It have to be a string because, right, we're using strings everywhere, right? The questions, the questions, our questions schema, the IDs are strings. So this has to be string. And in this model, right, is going to be the model of the question that we're going to create in a minute. Right? And what this is going to allow us to do is to have the quizzes have multiple references to the questions, right? So that we can establish a one-to-many relationship between the quizzes and the questions. We can say that this quiz is made up of all those questions over there, right? And we're going to maintain a link or a reference, like a foreign key, right, from the quizzes pointing to the questions that make up that quiz. All right. So let's create the model. We haven't created the model for the quiz yet, right? We only created the schema. We never created the model. So let's go on and create the model. I just want to make sure the model. Yeah, exactly. Right. This is just like we did for the quizzes model. This is exactly what we did, right? There it is. So quizzes, we got the schema, excuse me, created the model in terms of the quizzes, right? Same thing with the question. Let's add the model for the questions. So under the question, we're going to create a new file. Would be the question models, and it's going to be what? We're going to do the same thing we did earlier, right? We're going to load Mongoose, const Mongoose, require Mongoose. We're going to load the schema for the questions, right? So it'll be questions schema, require. And so schema, there it is, question. Now we can create the model in terms of the width of the schema. It'll be questions model. It'll be Mongoose model. Again, the first argument is a unique identifier. So we're going to call it with questions model. And the second argument is the schema, the question schema. There we go. And then we just export it. So module.export the question model. So now we can rewrite our service in terms of this model, right? So we go back to our service, the question controller, service, sorry, question service. There we go, question service. We can start replacing these two functions, right? Retrieving all questions, right? Instead of retrieving it from the questions, we can use the model, right? So let's bring in the model. So questions model require, we go up one and then down db and then questions and then model. Okay, so instead of using this synchronous call, we're going to return whatever the questions model has for find. Again, find, remember, retrieves all the fields, right? All the records, okay, if you don't provide any filter. And for the find question for quiz, we can do something similar. Right. Well, actually, let's try this one first. Find all questions. Find all questions. So if we implemented it this way, right, we need to re-implement the controller because the controller is expecting this to be, right, this question, right, this final question is expecting it to be synchronous, but it's not synchronous anymore, right? So I'm going to replace that. So we're going to call the question service. So the same call that we had earlier, the same exact call, but now it's not synchronous, it's asynchronous. So it returns a promise, right? And these will be all our questions, which we are going to send back. Go. All right. Let's see if this works. Let's restart the server. Let's see if we can get all the questions. So there'll be question API questions. There we go. So we have 1, 2, 3 questions. That's all we had inserted, right? Right. If we say final question, we have 1, 2, 3 questions, right? 1, 2, 3, 2, 3, 4, and 3, 4, 5. 1, 2, 3, 2, 3, 4, and 3, 4, 5. So yeah. So that is coming straight from the database, right? Let's go on a little further, and let's now replace. Let's replace now the find questions for quiz. That's going to be a little bit interesting, right? Because we need to filter, right? In the database, we would say, you know, we have the quiz ID, right? We have the quiz ID, so 234, 234, 234. I guess all the questions are for the first question, 234. Let's make this a little more interesting. Let's insert yet another question. Let's see. Let's insert. Let's see. Somebody that is the quiz ID is different than 234. Let's do this one. Okay, so let's insert this one for quiz ID 345. Copy that, and let's insert. So db dot questions dot insert paste close parentheses up. That didn't seem to work. Let's try it again. db dot questions dot insert. Okay, let's copy this. Copy. Let's paste that. All right. Enter. Looks like that works. Let's find all the questions. So we have, there we go. We have 1 question that is 345, and then 3 questions that are 234. Okay, I think that's enough to test at least. Right. So yeah, so find questions for quiz in the service is going to use, it's going to return whatever the model is, find. So yeah, so in the database, we would do something like this. We would say db dot questions find, and we can provide here a filter. It says, well, we don't want all of them. You can provide here a criteria by which, you know, which questions you want. I want the question whose quiz ID, so quiz ID is equal to, say, 234. And indeed, it comes back with 3 questions. But we added a new one, right? We added one that it's 345. Let's try that. Notice that this one only returns 1, right? So that query works, right? So let's instead of doing it here manually, let's see if we can do this programmatically. So this is what we need. So let's copy that. So yeah, so it's quiz ID, but not hard coded. It'll be whatever parameter you pass in here. Quiz ID. Okay, and that gets returned. Who receives this? The controller, right? The question controller. So let's see, controller, question controller. There it is. So the question controller instead of using this synchronous implementation, well, this one we need, right? It retrieves a quiz ID as an argument, as a parameter, and then we can use that to retrieve this. We can say we can use the same query, which we just rewrote, right? Find questions for quiz, but this time around, it's not going to return an array. Instead, it's going to return a promise, right? And this comes back with presumably the questions that match that quiz, and then we can send back the response. Okay, there we go. All right, let's try it out. Let's start the server again. So yeah, so these are all the questions. So we can say questions for quiz. So I think it's a quizzes 1, 2, 3. Actually, no. Well, this one has no quizzes, no questions. But how about 2, 3, 4? The 3 that we wanted. There we go. And we know that we had 1 question in 3, 4, 5. There it is. Okay, there it is. So it's working, right? It's retrieving data from the database. This makes sense? Is everybody still with me? Right. So we were able to in the service, right, completely replace this here, right? So we can just comment it out. We don't need it anymore, right? Because it's not being used anywhere. No, wait. Find question. Oh, we never implemented this one. How about that one? Let's implement this one too. Right? Comment it out. This is retrieving a particular quiz by their ID. We can do that too, right? So we can say that's question model dot find by ID, right? QUID. There it is. And in the controller, I don't know if we even use this. We didn't. We didn't even use it. we never used this, but nevertheless, we were able to re-implement it. All right. Any questions? Let's see. Is there a question on the chat? No questions from the chat. Okay. Okay. All right. Let's keep looking at this. So notice that, right? If we go back and take a look at not the quizzes, but the quizzes. If you look at the quizzes, okay. Notice that we added this new questions array, right? We had this questions array that typically would have references to quizzes. So for instance, we know that quiz 2, 3, 4 has 3 questions, right? Is that so? Is it quizzes, then 2, 3, 4. We have questions. Yeah, we have 3 questions. See that? And their IDs are 1, 2, 3, 2, 3, 4, and 3, 4, 5. Right? So the way it would be, the way you could represent this is 2 different ways. Right? You can represent it this way, where the children, the questions have references to their parents, or their parent has references to all their children. Right. So right now it's implemented as the questions have references to the parent quiz, but we could have implemented it the other way around. We could have implemented it where the quizzes have references to their children. Right. A quiz has arrays to their children, and the way that we implemented is that this would include, according to the question schema, the type here would be that it would be, oh no, wait, not question, the quizzes schema, yeah, right, that the questions, the type is string. See that? which is fine because those are the actual data types, 1, 2, 3, 2, 3, 4, so on and so forth, right? So the way it would be stored in the database would be as follows. So you have db.quizzes.find. Dyslexic here. Right, is that, for instance, quiz 234, we know that it has 3 questions, right? Which questions? Well, according to this, the questions for 234 are these: 1, 2, 3, 2, 3, 4, and 3, 4, 5. Those are the 3 questions for quiz 234. So the way it would be implemented here in the database, it would be that as follows. You would say db.quizzes, right? I'm going to update the quiz. I'm going to update the quiz whose ID is 234. Okay. I'm going to set, right, the quizzes array to contain these 3 quizzes: 1, 2, 3, 2, 3, 4, and 3, 4, 5. Right. So let's do that. So it's going to be 3 strings of the quizzes that belong to this, of the questions that belong to this quiz. So I'm sorry, not quizzes, questions. Okay. So this would be 1, 2, 3, 2, 3, 4, and 3, 4, 5. Okay. So let's take a look at the quizzes again. There we go. So now notice that this quiz has these IDs. Now, as far as a quiz is concerned, this is just an array of strings. That's all they are. There's nothing special about those strings. But from the excuse me, from the let's see, from Mongoose point of view, look at the quizzes right now. Notice that, right, our quiz 234 here, 234, has now a questions of 1, 2, 3. We just inserted these, right? We just updated it, right? But notice that they're showing it at like strings, just like strings. Okay, but there's some magic that we can use a spell here, because we said that these are strings. Yes, we said that these questions, oh my goodness, excuse me. These questions, yes, they are arrays of strings, yes, but we additionally said that these are references to questions models. So what are questions model? Well, if you remember when we created the questions model, where is it? Question schema, questions model, we called it like that, exactly the same. See that questions model is the same as this reference questions model. See that? And we did that deliberately. What this allows us to do now is we can tell Mongoose, not MongoDB. What we tell Mongoose is to apply a cross-reference and say, hey, you don't have these strings here, have these strings. I'd love to have the actual pieces of data, the actual question objects, right? So we can ask Mongoose to replace these IDs with the actual objects that are mapped in the database for those IDs. Okay, it's almost like a join, right, in a relational database. In a relational database, the way you do that, right, if you have 2 tables where you have some data stored in one table, you have some data stored in another table, you can have these IDs that, right, are live in one table that are referencing records in another table. You can join them and say, hey, fetch for me the records in that table that match the ID over here and bring them over, bring the data over, right? So we can do something like this, right? Not using Mongo because Mongo doesn't support joins, right? This is all application based, right? Mongoose, the library is going to do this for us. Let's do it. So for instance, here where we retrieve the quizzes, right? When we retrieve the quizzes, let's not do it here, actually. Let's not do it here. Let's do it when we retrieve a particular quiz. So for instance, let's say we retrieve 2, 3, 4, right? When we retrieve the quiz, it'd be nice to have the questions. Not here, probably not here when we ask for all the quizzes, because this would be a waste, right, to fill in all the questions on a quiz that we might only be displaying the title. Maybe we're displaying just a title. Why bother populating the data for the questions if we're not even going to use them? But if instead you're going and retrieving a particular quiz, then here it might make sense that instead of the IDs of the questions, I would want to see the actual questions. Let's replace that implementation. Let's go here and let's go into the service, into the quizzes service. So here where we are retrieving the actual quiz by their ID, what we can do is the following. We can append to this a couple of transformations. We can append a couple of transformations. We can say dot, okay, you can say populate, meaning I want you to go in and replace these questions, their IDs. I want you to populate them. I don't want the IDs. I want the actual value. So we can say populate the questions. Populate the questions. Okay. Dot execute. Okay. This is kind of like a little script, right? Because you can actually, if your data models are fairly complex and you have references going everywhere, right? You might want to replace these and do that and transform that and the other, right? So you can have many transformations. In this particular case, it's the populate transformation, right? And then you need to compile all that and then go out and do it, right? Because what is this going to do? Well, it's going to say, oh, well, now I have all these 3 IDs. I'm going to have to go do another query. I'm going to have to go and ask for these questions to the database, right? And then replace these with the actual objects. So this entails doing additional work, additional fetching to the database, right? So let's try it out. Let's try this out. Let's restart the server and let's refresh. There we have it. See that? Look at that, right? Now, when we ask for the questions, we don't get the IDs anymore. We get the actual questions, right? With the choices and everything. See that? Now when we get the list of quizzes, right, it would be a shame to fetch also the questions for this. Although we could do it, but it would make no sense, really, right? Because at this point, it's a high-level query of I just want to list all the quizzes. Right, it would make no sense to retrieve the question. It would be a wasted, amount of CPU and whatnot. Okay. All right, so there it is. So I'm going to push this so that you can take a look at this and keep working. Feel free to use any or none of this material for your own purposes, for the assignment or for your project. Okay. All right, any questions? Actually, I think actually I think I have a couple more minutes actually. No. Let's take a look at doing some additional transformations, right? So we did all the retrievals, right? We did find by ID. We did find by a particular field. Let's see, is there a question in the chat? What would happen if you inserted a question that didn't have a matching ID? What if you inserted a question that didn't have a match? Yeah, there is no referential integrity. There's no validation Okay, that would be all entirely up to the application level, right? So it would be the application level who would validate, right, that the IDs that you're providing are valid. There's a question in the chat. How would you handle cookies sign in for this JavaScript server? Cookies sign in for this JavaScript server. Cookies. Okay. User authentication. All right. We can chat about that. Let's see. Say you had a user, right? And so you'd have maybe user, new directory, users, and we can create here a schema for users. So this might be users schema. Actually, I think we had some users here, no? db.users.find. Yeah, we have a couple of users. Okay, and so this would be const mongoose require mongoose and const user schema. This would be mongoose dot schema, and this has what has first name is a string, last name is a string, and finally you have username and password. Okay, and this matches a collection of users. Okay, we're gonna export this. So module export and user schema. Okay, for the cookie. Okay, let's see. We did not have cookies here. So for the cookies, we're going to use a library that handles cookies, and it's called Express Session. I think it's called. Yeah, Express Session. So Express Session can handle cookies, and so we're going to install that. Let's install it. And so terminal install save. Okay, that installed it, and we're going to require that. I'm going to require it, and so let's see. Let's do it right here. So const session const, and then you can configure the session down here and say use app session. There we go. And so here. We're not going to do secure. Secure, I mean, yes, you want secure, but secure only works if you're using HTTPS, which we don't have HTTPS running here on our server. And this will work on Heroku. Heroku does support HTTPS, but for real true HTTPS, you need to pay Heroku. So if you really want HTTPS, in Heroku, you need to pay a fee, whatever, I forget what it is, $5 a month or something. Since I don't have HTTPS, I'm going to turn off secure. Right? I don't have, we don't have HTTPS. There it is. So there we have session. Okay. So what we're going to do? Let's do a register. Let's do a register. So here let's create a model here. We'll say JavaScript users model. And this will be, we'll say const user schema require user schema. We'll need a mongoose. We'll require mongoose, and we're going to create the user's model. This will be mongoose dot model, and this will be oh, what do we call this question model? and we call this question model and quiz model. Okay, this one we're going to call user model. So user model, and the schema is user schema. Okay, perfect. And we're going to export this. So module.exports the user's model. All right, once we have that, we can have a service, right? And so this will be a user service. Well, actually, let's skip over to the controller so that, so this will be users controller. And in here, you're going to have the same thing, right? That's always module.exports app. And here you're going to have, for instance, what do you have? You have const register. And in register, you're going to have request response. And you're going to have a app.post, right? If you want to register, be API register, something like that. Register. So I'm going to call register like that. And you're going to have all the different ones here will be register, login, log out, right? If we look at the current profile, and for each one of these, so let's implement these. So this will be register, login, log out, and profile. There we go. So to register, basically what you want to do is you create a new user in the database, right? So you need the model. So const user model or users model, I forget, right? And you would require that. So require, you're going to go up 1 dB, and then users, and then user model. There we go. So you want to create a new user. So where do you get the user? So the user, you get it from the body. Is a request.body dot and you store it in a local const the user. This is a user that came in that is registering, including username, password, blah blah blah, and you're going to store it in the database. Right? You're going to say users model dot create. So create is the same as insert, right? So you're going to insert user, right? And so the user is going to come back. Then this would live in the service, right? I'm taking a shortcut. This would be in the service. So to do this to a service file, right? So yeah, so this comes back with the actual user that has been inserted into the database, right? With an ID and everything. And so what we're going to do is that we want to store that in the session as saying that this person is logged in, right? You just registered, right? You have a username, a password, blah, blah, blah. We want to store it in the session. We're going to say request.session. So, this library, this session library adds to your request, adds this session. And this session, you can treat it as if it were a hash table, right? So you can say session, right, dot or current user, right? You can say it's equal to the actual user. Okay, so now this current user is in the session, okay? And we're going to return, we can return maybe do a response dot send back the actual user. You might want to remove the password. You don't want to send passwords back to the client. So in the profile, right, once I logged in, I can retrieve the current logged in user from the response, from the session. I can say const current user from the session. So request.session. I had stored it in the current session. That's where I stored it. So current user, I think I called it, right? Current user, yep. And then I can send it back in the response. Response.send back the current user. Now this might be null, right? If you go in here and there is no current user, right? Then because you haven't logged in yet, this will fail, right? You have to handle that on the client side. For the logout, you can say, I think it's a request.session. Crap, I forget. Fine. Equal null, maybe? I forget, equal null. I forget, expire, maybe? Expire. Use cookie. There's a function to cancel the session. I forget what the function is. I'll look it up. And for login, right? You bring in the user. You bring in the user just like in the register. Just like in the register, and you look up that user. You look that user up to see if the user exists. Right? You can say user model dot, you're going to find the user that matches, where the username is equal to the user that you passed in. You passed in a username, presumably in the body, and you also pass a password, right? So let's see if that user exists. So we are matching by password, right? User.password, password. Okay. Then this comes back as the actual user. Now this user might be null because the user never existed, right? That user doesn't exist. So you check to see, if there is an actual user, then that means that we have successfully logged in. It says, okay, this user actually exists in the database. So I'm going to make this user the current user. So it's going to be request.session, current user, right, is equal to the actual user. Okay. And I can respond. I can respond now and send back the actual user. Otherwise, else, meaning that user doesn't exist, you could send back an error. You can send back a did not find user. I can say respond sent back, I think it's 4.3 or something. 4.3 meaning I think it's unsecure or authentication failed or something. Same thing with the profile, right? If, right here you can do, if you have a current user, then right you come back and send back the response. Otherwise, you send back response, send back a 4.3 saying, authentication failed, you're not allowed, right? And obviously the client needs to handle this error message. Okay. Here I forget how to. I think I have some slides on that. Let me see. Modules. Node.js, blah, 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 Mongo employees, creating user model, Mongoose, session, maintaining session in Node.js. Here we go, maintaining sessions in Node.js. So yeah, Node.js session walks you through what we just talked about, right? You install express session, right? And set session. So this gives you a couple of examples on how to parse JSON, setting up course. If you are using cookies, allow origins, right? If you're using cookies, this allow origins cannot be star, right? Because cookies is secure, you're passing password around, so it's not, you can't go across origin. You have to explicitly say what if it's localhost or it's Heroku URL. This needs to be explicitly a particular URL. Where's the logic that handles one person's session being different from? No, all that is behind the scenes. You don't handle that at all. Right? By the time you get to this controller, this session This session, right? If it's Alice, Alice will have a different cookie than Bob, right? So this current user, right, for Alice will be one session, and for Bob it'll be a different session. That is handled automatically for you. You do not handle the cookies whatsoever, right? The cookie is used as an index, right, to give you the correct session, right? So that if Alice is talking to you or Bob is talking to you, they both send in different cookies. So this session will be different for Alice or Bob. Yeah, you don't handle that at all. Yeah, that's all handled under hood. Yep, exactly. All right, folks. That's all I have for you. We will do more of this next week. We'll play around with implementing more authentication and login and registration. Excellent. All right. All right. Thank you.